Hi there, this is Jacob Nash, Precalculus Lessons, and this is Unit 2, Lesson 8 on a logistic problem. So this isn't exactly the same as like a logarithm, but it's just a logistic. So here we have a problem, and in this kind of problem that you might see, there are limits. So the graph of an exponential function, as we know, looks like that. So it just keeps going up. But this kind, it's like, well, it's going up, but then it just kind of flattens out. So this is what kind we have in this problem. And of course, I use MacGyver as usual, that's because that's the only thing I can think of. So also, the highest slope is half of the maximum y value. So what that means is if you want to know when the slope is the steepest, it's half of the maximum y value. So we'll look at that. And they have equations that have like the e like that, and there's like a fraction. So in the show MacGyver, there's someone that's bad. Well, there's pretty much someone bad in every episode, but a reoccurring bad character is named Murdoch. That's what that is in that picture, both pictures, and he always gets defeated by MacGyver, and you think that he might be dead, but every time he's not dead somehow. But this is one episode. I don't know if it's the last episode he even was in, but in an episode called Obsessed, as usual, Murdoch is trying to kill MacGyver. This time, well, if you see this picture to the left, first he tried to make him get toasted by some rocket thing, but that didn't work. So then he's trying to crash into him with his Jeep. That's what this bigger picture is. So that's him trying to crash into him with his Jeep. And the equation shows that Murdoch is 4,570 feet away from MacGyver. He won't reach MacGyver because he crashes his Jeep off of a cliff by accident. That's what happens in the episode, actually. T represents the time in seconds that it takes Murdoch to drive. So seconds. He advances a little bit before hitting the pedal. That's what he does. And in this episode, he falls off of the cliff, and when that happens, the Jeep explodes, but once again, it's assumed that he doesn't die. But I haven't watched every episode, so I don't know if he actually does come back or not. But anyways, so this is the equation, f of t. So f, let's assume that's feet. So how many feet does Murdoch go in his Jeep to try to crash into MacGyver? And then on the numerator shows you what the maximum value is, but it cannot be reached. That's what I already said up here. So Murdoch is not going to be able to get to MacGyver because he crashes off of a cliff first. And then what's in the denominator kind of just seems like gibberish, so it doesn't really matter what that means right now. But also that E means about 2.72. So we have A, B, C, and D questions to answer, and we got to figure it out. So our X values, let's just go ahead and write this down so that we understand what this thing is about. So our X values, that is really what our T is, and that is time, and the units for that is seconds. And then our Y value is distance, and that is in feet. So for a certain amount of time, how far does he go? And you can see, I told you that the graph of a logistic graph looks like that. So he starts out and then he hits the gas and goes quicker, but then it drops off here because that's where he crashes because he can't get to MacGyver. So that's what this is. So hopefully that will make things a little simpler. How far is the Jeep from MacGyver after Murdoch advances? Don't say 4,570 70 because it says that he advances a little bit. How do we know what this is? Well, this is going to be f of 0. Well, really, that's the uppercase f. So that means when time is 0, what's the distance before Murdoch starts? How do we figure that out? We have to plug in 0 for t. So what we're going to end up doing in the calculator is this. Typing in this. Okay. And since I got my new app thing, let me go ahead and use that so that I can type that in. Okay. Let's clear that. So we want, since we're having a fraction like that, let's just do alpha y equals number 1. And let's put that in numerator, then denominator 1 plus 55 e. We have to do second ln to get to that, and then negative 0.8 times 0. What do we get? We get that he is 81 feet. Well, actually, that's not a very. The question's kind of worded wrong. It shouldn't be how far is he from MacGyver. It's really how far is he from the starting point. Because obviously he's not 81 feet from MacGyver. That would be advancing a lot. So that is, well, really, if you round, that's 82. So the proper way to answer is f of 0 equals 82 feet. So when he advances, he gets to 82 feet. So if you subtract that from 4570, he has to still go 4,488 feet to get to MacGyver, but that's not going to happen. Okay, good. How long until Murdoch is 4,000 feet away from his original starting point? This time we're given the output, and remember that's what we did in the last video. So we don't plug in 4,000 for t, we plug in 4,000 for f of t. So we are going to do this. Let me just zoom this in so you can see better what I'm doing. Okay. And that was E. Okay. And I said there was 2 ways to do this. We can use the log function or graphing. This case, I think graphing is easier because it's not very easy to do the log thing for one like this. So, and one equation we're going to type in this problem, alpha y equals okay, and then below 1 plus 55, oh, not 555, e to the negative 0.8. We can't do t, so we'll do x. That's in that one. Then in the second one, we need to do 4,000. Then we need to graph it to where we can see the intersection of both. Can we? We can see that. Oh, we can. So we don't even have to adjust the windows this time. So as you can see by what the graph shows, Murdoch, he has started here, and we're making time 0 after he advances. So a negative time, so before time 0, that's when he's 4,570 feet away from him. And that's when it equals 0. If you were to look at this graph, it doesn't have a y-intercept at 0, 0. It has a y-intercept at 0, 82. That's what we found in the last problem. So y does not equal 0 before the time starts because he advances. So we can see that he speeds up by putting on the gas, but why does the graph go flat? Well, unfortunately for Murdoch, it's because he crashed off a cliff and his y value of distance could not increase anymore because he crashed. And so we need to figure out whatever this intersection is when he's 4,000 feet away. So that means he's almost to where he crashes, but he never will get to MacGyver. So we need to do second trace intersection and just push enter until you see the answer, intersection at 7.44 4,000. So we can say 7.4 seconds. So it takes Murdoch 7.4 seconds to go 4,000 feet. And that's actually, once again, this problem is incorrect. It's not 4,000 feet away from, oh wait, actually that is right. 4,000 feet away from his original point, not from MacGyver. He's 570 feet away from MacGyver, but once again, he won't get there. Okay, how long does it take Murdoch to get to his final speed, or highest speed? So remember I said at the beginning that the highest speed, that would mean the steepest slope, is going to be the total, the maximum, which is always the numerator, which happens to be 4,570, and you have to divide that by 2 to figure out that at least tells us the distance. So we're dividing that by 2. 2285. So 2285 feet. So when he gets to 2285 feet, that is when he's going the fastest. Because remember the graph, it was like that and then that. And so that means we use this as our y value like we did in the last problem. And scroll up a little bit so I can make sure I know that equation. 1 plus 55e. So now we're going to go back to the calculator and we go to y equals. All we need to change is make that 4,000 2285 instead. And let's adjust our window. The maximum doesn't need to be 8,000. We can make it 3,000. I think I just clicked on something, so it's probably going to pop up. Sorry. Okay. Now we're graphing. Okay, there's that one. And at that intersection, that's where the slope is the steepest. So once again, second trace, intersection. And we see the time of 5 seconds. Okay, so it takes Murdoch 5 seconds to go to his high speed. That doesn't mean that the total time is 10 seconds. Don't think that. Around what time does Murdoch crash off of a cliff? So we know, what is one thing we know? Since this is a logistic problem, the y value will never equal the numerator, which is, oh, forgot the number already, 4570. 4570. It will never equal 4570. So since it says around what time, it's going to be around when we get to that value, but let's say 4569. Let's say that, since that is a value that he can reach. So this is going to be an accurate thing we can do. So we can do this. Same thing as last time. Now we go back to the calculator. Now change the 2285 to 4569. Put in the Y3. Oh, whatever. That's just what I'll have to do. Window, this time we're going to have to change that to just say 55,000 or 5,500. Okay, so there's that. That's where he works flat. That's where he crashed. Oh, look at that. That is so hard to tell. where the intersection is. So we're actually going to have to change the x minimum or y minimum because of how that is. So let's make our y minimum not 0. Let's make it 4,400 so that we can better see the intersection. Okay, there's that first graph. Yeah, that's actually not much better. Let's go back to the window. We can make this 4575 and 4565. See how that is. Okay, there's the graph. Hey, there we go. That's better. Now, intersection. Second trace. Intersection. So, at 15.54 seconds, that is about when he crashes off, because that is so close to 4570 feet, which he never does reach. He really, what the highest value that he reaches is 4569.999 repeating. That is what his final distance is. But we just went ahead and did that. And so that is about what it is when he crashes off the Jeep. It was probably just a tad bit more. But so that is how you do a logistic problem, and hopefully that makes sense. But you are either just going to be looking at an output or input. You just need to understand what the question is asking. So that'll be it for this video. Thanks for watching, and I'll see you on the next one.